Hello, hi there, everyone. This is the continuation of our lessons in binomial distribution and, of course, of probability distributions. This is talking about the mean and variance of random variables, to be exact, discrete random variables. So our lesson objectives for this lesson are to illustrate the mean and variance of discrete and continuous random variables. We will be also calculating the mean and variance of random variables and also solve problems related to the mean and variance and interpret the results given by those numbers. For discrete random variables, uh, the mean or the expected value mu, which is the population mean, is the weighted average of all possible values of the random variable we have. And the variance, denoted by sigma squared, is the measure of spread or distribution or dispersion rather. It is a measure of variation of the values of the random variable from the mean. So how spread they are away from the mean or how near to the mean. And the standard deviation, of course, a sigma is the square root of the variance we have. The formulas for the probability of x equals x is denoted by this. The mean is equal to the mu, rather the mu is equal to the summation, the sum, in a while, the sum of all the products of x times p of x. So it's just simply the random variable multiplied the probability of it happening. You sum all of that, and that's going to be your expected value. Your variance is equal to the summation of the deviation squared. So this is a deviation, x minus mean. You square all of that, and then you multiply that to the probability of each corresponding random variable here. So whatever the probability of that happening, you put that in here in the x, you get the mu from the mean, and then you square it. This is what we call a deviation. You square the deviation, and then you multiply that at each probability that we have, and then you sum them all up. So it's quite a twisted formula. That's why we have a shortcut formula later to show you. And for the standard deviation, so well, it's just you just need to get the square root of the variance. So we can fix this formula by simplifying our notation of p of x equals x. Let's just simply make it p of x for it not to be an isor. So we have these formulas in a simpler version. Okay, so let's try to work out some examples. Say students were asked to estimate the length in inches of a table, to say a teacher's table, and the errors in the estimations they give were recorded and tabulated as follows. Let's say this is in inches. The probability or the number of errors, um, the probability that there are three errors is 25%. The probability of having an error of 3 inches, okay, is 25%. The probability of having an error of 4 inches is 10%. Probability of having an error which is 5 inches is 30%, 6 inches is 15%, and 7 inches is 20%. So we want to find the mean value or the mean error of this probability distribution, and we will then determine the variance and the standard deviation. So before we move on, there's some note here that there's an alternative formula for the variance which actually makes our lives easier. What we just need to do is we just need to square each random variable x, and then you multiply that squared value by the probability of it happening. You sum them all up, and then overall you minus it to the mean squared or the expected value squared. So that will be our sigma squared or variance. So remember that the standard deviation is just a root of the variance, square root of the variance. So we can just have it from there. So how do we solve this? We can have it using our calculator. So need to multiply this one. 3 times 0.25 is 0.75. Let me write that down. 0.75. 4 times 0.1 is 0.4. 5 times 0.3 is what's that gonna be? 0.15, okay, or 1.5 rather. 0.15 times 6, what's that? 0.15, 0.3, 0.9, 0.9. And we have 7 times 0.2 is gonna be 1.4. And then you just need to sum them up because that's what the mean wants us to do. 0.75 times point plus 0.4 is going to be 1.14. To be sure, let's have a calculator here. Have it ready, I guess. Here it is. So here's the sum. There are the sums there. So we have 0.75. I'm gonna add that with 0.4, then 1.5, and then 0.9, and then 1.4. Get the sum, and then what you'll have is the number 4.95. So meaning the probability or the expected value if ever you're gonna do this experiment to a certain student would be 4.95, or the most probable error that one may have is 4.95 or 5 errors, 4.95 inches. Now for the variance, let's follow this alternate formula because this formula is quite easy, much easier to follow rather than the one before. So 3 squared becomes 9, 4 squared becomes 16, um, 5 squared becomes 25, 6 squared becomes 36, and 7 squared becomes 49. And we multiply each of this to the probability of it happening. So say 9 times 0.25, make use of that. So actually we can rewrite that directly to that in the calculator. So I think you can see the numbers there. So 9 times 0.25, we add that to 16 times 0.1. 16 times, well, we can get this. Oh, it's going to be 1.6, but I'll just show you how it works in a calculator now. So 5 times 0.3, sorry, 25 times 0.03, 0.3, okay, 25 times 0.3 plus 36 times 0.15, 36 times 0.15 plus 7, or rather 49 times 49 times 0.2. So we're gonna enter this, and the variance that we have is quite wrong. Okay, so there's something wrong with the thing that we have. So we have 9. Let us double check the equation we got. 9 times 0.25, 16 times 0.01. That's right. 25 times 0.03, 36 times 0.15, and 49 times 0.02. Okay, so that's 26.5. Um, right after that, we need to subtract that by your mu, which is 4.95, which is quite a wrong thing here. So let's double check. You can so the formula says you're gonna square the error first, you multiply that to the probability. So 9 times 0.25, this is correct. 16.01, 25 times 0.03, 36 times 0.15, 49 times 0.02. So we can double check it here. Try to look at the sums. And we're gonna sum them up. Hmm. Well, it feels like there's something wrong with the formula. Let us double check this. This is 9, right? 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. 9, 16, 25, 36, 49. Add that. Oh, all right. I guess the wrong thing that we forgot is we need to minus this to the mean. Remember the mean is 4.95. So we need to minus this by 4.95. And remember that it should be squared, which we forgot to input. So 49.25 squared is equal to 2.0475. Can we round it up to the second decimal place? 2.05. And that makes our answer correct this time. We forgot that this last part of the formula. And we're going to get the square root of this. So, okay, get the square root. Yeah. So 1.43. Okay. So the answer that we have is um 4.95 for the mean, 2.05 for the variance, and 1.43 for the standard deviation. And that's an example on how to determine the mean and variance of random variables. I guess we will stop here. Okay, we'll have a breather first, and let's see each other in the next video. So thank you very much.